To demonstrate the components of the analysis of variance output, we'll use created data for 3 groups, each with 5 observations per group, with 2 measuring mechanisms, one that produces narrow variability and one that produces wide variability. You could think about this as using a machine to calculate blood pressure versus as using manual methods to calculate or determine blood pressure. So we'll first start out by using the narrow group. So we'll go to Analyze, Fit Y by X, and we'll put group as our X and narrow as our Y. You can see here that our group values that are nominal and our Y value that is continuous will get us a one-way analysis of variance. Press OK. We get a very generic graph here with our groups as the x-axis and our narrow response on the y-axis. I'm going to go ahead and change the scale of this to 450 by 450 so that we have a square graph with a little bit larger. Also at this time I'm going to do the Analyze Fit Y by X and put group as our X and wide as our Y. And we'll do the same thing here with our size and scale to be 450, 450. You could do these both in the same Analyze menu, but we want to compare them side by side here rather than in a vertical manner. So we can take a look, comparison of the narrow variability versus the wide variability. So the first thing we should know is that we don't have similar axes, and so what we want to do here on the narrow is change our axis setting, and that's by right-clicking or control-click an axis setting, and we're going to go from 75 to 130, and we want to show it by 10, increments by 10, and press OK. And that puts our 2 sets of data on the same scale here with the Y. And what we can see here is that in the narrow group, we have much tighter packed observations or less observable variability as compared to our wide group. What you can also see though is that the mean for both groups is identical, as is the mean for each group is identical. So we can get our means and standard deviations for both of our narrow versus wide. And what we can see here is that they are in fact identical. So identical means, identical means, identical overall mean. But what we can notice is that our standard deviation in the narrow group is much narrower or smaller than the standard deviation in the wide group. This is of course by design. Consequently, we have narrower confidence bounds in the narrow group than we do in the wide group. So if we wanted to do an analysis of variance, we could ask for the ANOVA here. And the parts of the ANOVA that we want to talk about, first of all, in the graph, is that we've got the ANOVA diamonds. They are much more compact here in the narrow group than they are in the wide group. And then also, aside from those results, we want to take a look at what we get for our ANOVA results. So what you'll get is this summary of fit. You'll get the ANOVA table, which is where the sum of squares for your model, your error, and your total. Remember, the sum of squares total is all we have to work with. So every y, if you estimate the mean of y, will give you a sum of squares total. And then we can get the mean square, and then the F ratio, and then our p-value associated with that. And then you'll also see a means and standard error table. And in our case, the means will be identical to what we saw before. The standard errors will be shown, and then our confidence bounds. And those are the same as in the means and standard deviations report, which if I bring up here, you can see that the means for these match, means and standard errors match. But what you don't get in the ANOVA table is the standard deviation. And when you are summarizing your sample, you want the standard deviation. Also note that JUMP has told us that we have standard error using a pooled estimate for error variance. So this was an equal variance ANOVA. What you want to take a look at or pay attention to are the components of the analysis of variance report. This will give you your p-value for your overall f-test of is there a difference between the groups. The follow-up question for that is where is there a difference? So we're first asking if we can use this mean to estimate our y, or if we need to have at least two means. If the answer is we need more than one mean, which is what is being indicated here, then we would need to do a follow-up test to determine do we need two means or three means. If you'll notice, between our groups here, the narrow and the wide, the narrow is telling us that we have a difference, whereas the wide is telling us that we do not have a difference between the group means. And this is due solely because of the difference in the variability. These groups have very little variance within each group, and therefore that allows us to say that the means are different, whereas in the wide group, we have a lot of variability within the groups, and therefore our means across the groups are not different. What you can see is that the group value, the sum of squares associated with the group value, is the same in both models. It's the same in both models. What has changed is our total sum of squares and our sum of squares error. The total sum of squares is different here because we have different observations. And our sum of squares error is much larger because we can see, visually see, that we have much bigger variability here. So though we have the same set of means by group, we are getting two different results for a hypothesis test of equal means because one group has much larger variability. And that is the essence of analysis of variance. We are comparing the means across the groups with an estimate of the variability within group. The smaller the variability, the more likely you are to say that means are different. The larger the variability, the more likely you are to say that means are similar. So you really need to keep an eye on a description for your data and understanding what your means are and what your standard deviations are. And then pay attention to your ANOVA sections and your main ANOVA test result. In the next video, we'll look at how to determine an F difference or an F test for some real data, as well as then if we say that we have a difference in means, finding where that difference is.